If you look around today, quality control in construction, in manufacturing,
Yeah.
it's just fundamental now, isn't it?
Absolutely. It's everywhere.
And it's really driven by, well, global competition, safety rules getting tougher, and honestly, just how complex things have become.
Yeah, the designs we're seeing now are way less conservative than, say, 50 years ago. Much more demanding.
Exactly. Which puts one particular role squarely in the spotlight, the welding inspector.
Yeah.
So today's deep dive is really designed to give you a bit of a knowledge boost, an edge. We're going to provide an audio overview of a really foundational textbook, Welding Inspection Technology. If you're gearing up for that Certified Welding Inspector exam, the CWI, then this discussion should really help you get your studies organized and lock down the critical stuff. Today's episode is brought to you by AMS Level 3. AMS Level 3 provides consulting, training, and compliance solutions to help companies build stronger non-destructive testing programs. You can learn more about their services at the link in the video description.
And the book itself, Welding Inspection Technology, it's more than just a textbook, really. It's distilled professional practice.
Right.
It gives both new inspectors and, seasoned ones the essential background for those really critical parts of the job. Basically, the general knowledge you absolutely need to inspect effectively, no matter the industry.
And the scope of knowledge for the CWI is, well, it's huge when you look at it. The book has 11 chapters, but maybe instead of just listing them, we could think about them in, like, 3 main buckets.
Yeah, that makes sense.
Okay, so first you've got the fundamentals and governing principles. That's things like the basics of inspection, certification itself, safety practices, and all the documentation involved.
The groundwork.
Then there's the processes and properties.
Yeah.
So that covers how metals are joined, cutting processes, destructive testing, and the really big one, welding metallurgy.
Which is a beast in itself.
Well, yeah. And finally, bucket 3 is identification and evaluation. That's your weld joint geometry, figuring out discontinuities, visual inspection, and the other NDE methods.
It really shows it's not just about knowing how to weld, is it? It's about judging quality across this incredibly broad spectrum.
Totally.
Okay, so let's unpack that first chapter then. Define who the welding inspector actually is, and maybe more importantly, what the job really involves day to day, because it's way more than most people think.
That's the key takeaway, I think.
Yeah.
The notes really stress that a good quality control program starts way, way before any welding happens.
Exactly, long before the first arc is struck.
The inspector's job is constant, it's ongoing risk management, not just a final check at the end.
Precisely. And think about the economics of it. Those pre-weld checks, they're often the most valuable part. Because finding and fixing a problem before the weld is made, well, that can save maybe 10 times the cost compared to grinding out and repairing a weld that's already finished and failed.
Makes sense.
So this pre-weld stuff means checking drawings, specs, figuring out how much inspection is actually needed, identifying any special processing.
Yeah.
If you do all that right up front, the final look is really just confirming everything went according to plan.
And the inspection teams themselves, they have different structures, right?
Yeah.
The source mentions 3 general roles.
Yeah, broadly speaking.
You've got the overseer. That's often like the chief inspector managing other inspectors, their schedules, that kind of thing.
Yeah, the manager role.
Then there's the specialist. This person focuses on maybe 1 or 2 specific tasks. Often they're purely NDE specialists, right? Like RT or UT techs.
Exactly. Highly focused.
And then the most common one, apparently, is the combination overseer specialist.
Yeah, that's the reality for most inspectors out there. They're doing the general quality checks throughout the whole fabrication process, step by step, and they're also performing the necessary NDE themselves, like maybe mag particle or dye penetrant testing right there on the floor. They're the sort of general practitioners of weld inspection.
And the range of industries that need these folks is just massive. I mean, we're talking huge building a bridge projects.
Right. Infrastructure.
Energy sector stuff like power plants,
Yeah.
pipelines, chemical plants. And then the really high-spec areas like transportation, aerospace, automotive, even consumer goods manufacturing.
And that variety means the job complexity can be incredibly different from one place to another.
How so?
Well, think about it. The level of inspection needed for, say, a critical aerospace component, which falls under strict FAA or maybe military rules, is worlds apart from checking a structural steel beam for a local bridge.
Okay.
They both need that same core knowledge from the book, but how you apply it is super specialized, so the inspector has to be really adaptable.
So if the technical side is that vast and the jobs are so specialized, what about the person? What kind of individual actually succeeds as an inspector? What are those non-technical qualities you need. We'd also like to recognize Skaggs Media LLC as the creative force behind today's deep dive. Skaggs Media specializes in helping businesses build a strong presence on social media through strategy, content, and storytelling that connects. Find out more at skaggsmedia.com.
Okay, well, the sources jump straight to professionalism, and this is huge. It really boils down to being fair, impartial, and consistent all the time.
It sounds simple, but why is it hard?
Because you are constantly being tested, maybe not explicitly, but implicitly by others on the job. Production managers pushing schedules, welders who just want to get the job done, sometimes even engineers. They all have different priorities. An inspector's reputation is everything. It's really their only true asset. If you bend the rules just once, sign off on something marginal today because of pressure, well, that decision can haunt your entire career. It undermines everything.
Wow, serious stuff. And then there's the physical side. You mentioned adaptability.
Yeah, physical fitness. You have to be able to get to where the work is. Welds aren't always put in convenient spots, right?
Right, usually the opposite.
Exactly. So you need to be fit enough to safely use the same access gear the welders use: scaffolding, ladders, maybe even confined space entry equipment. You have to go where the weld is.
And part of that physical readiness is vision specifically.
Oh, absolutely crucial. The AWS CWI program has strict vision requirements. You have to pass an eye exam. Specifically, you need near vision acuity of Jaeger J2 at 12 inches or closer.
Jaeger J2. What does that mean in plain English?
It's basically the ability to read standard newspaper-sized print at about arm's length. And importantly, you also have to pass a color perception test.
Why color?
Because many NDE methods, like magnetic particle or liquid penetrant, often rely heavily on color contrast to see indications. If you can't distinguish the colors properly, you could miss a critical flaw.
Got it. Okay, what's next after professionalism and fitness?
Knowledge and experience. No shock there. And this is why you often see former welders moving into inspection.
Right, they already have that foundational knowledge.
Exactly. They understand the processes, so they can often anticipate where discontinuities might occur. They know, for instance, if the travel speed is off or the root gap is too tight, what kinds of flaws are likely to pop up.
So they can monitor things proactively.
Precisely. Prevent problems instead of just finding them later. But knowledge alone isn't enough. Experience is just irreplaceable. All the certification programs demand it, legally. And it's not just about ticking a box. Experience builds efficiency and helps develop that proper risk-aware attitude you need.
But even veterans need to keep learning.
Absolutely. The source mentions a documented willingness to get ongoing training. Codes change, technology evolves. You have to keep up to stay valuable.
Okay, moving to the more administrative side. Technical aptitude and record keeping.
Yes. Inspectors have to be able to read and, crucially, understand technical documents. We're talking blueprints, complex codes like AWS D1.1, various standards.
These are the rules of the game, essentially.
There are the objective criteria you use to judge quality. You can't possibly memorize them all, but you absolutely have to know how to navigate them, find the relevant section quickly and accurately.
And then record what you find.
Right. And the record keeping is incredibly strict. Reports have to be permanent. That means written in ink or typed, no pencil.
And mistakes.
This is critical. The textbook is very clear, and it's a legal requirement. If you make an error on a handwritten report, you must draw a single line through it so it's still legible, make the correction next to it, and then initial and date the change.
You can't just scribble it out or use whiteout.
Absolutely not. You are explicitly forbidden from totally obscuring the original mistake. It's all about transparency and traceability. If there's ever a question later, maybe a legal challenge, that clear record is vital.
Makes sense. Okay, last 2 points on qualities. Ethics and communication.
Yeah. Ethics is pretty much common sense and honesty, fundamentally. Decisions have to be based purely on the facts presented by the inspection, according to the code, regardless of who did the work or what the schedule pressure is.
A responsibility to the public, really.
Exactly. Inspectors have a duty to public safety. And part of that ethic is only taking on jobs you're actually qualified to perform.
And communication. You mentioned the different parties involved.
It's constant. It's not just the inspector telling people what's wrong. It's a continuous loop. The inspector is often the hub, right?
Right.
They need to talk to welders, maybe about a technical issue, like a root opening being too tight.
Or explain a symbol on the drawings.
Right. Or talk to the design engineer if a tolerance seems practically impossible to meet in production.
Yeah.
Or, the tough one, tell the production manager that a piece is rejected and it's going to impact the schedule.
Yeah, that can't be easy.
No, but clear, timely communication is key. The source gives a great example. A welder sees a fit-up issue, tells the inspector before welding. The inspector confirms it. That communication prevents a bad weld and a costly repair later. Saves everyone time, money, and grief.
So all these qualities, all this knowledge, it all points towards getting certified, doesn't it?
Yeah.
The AWS Certified Welding Inspector program.
That's the goal for many. It's the industry benchmark, really, governed globally by AWS standards, specifically QC1 and B5.1.
And there's a sort of ladder, right? It's not just the CWI.
Correct. The source material lays out two other related certifications. There's the Certified Associate Welding Inspector, or CAWI. That's kind of the entry-level position.
Requires less experience.
Yes, fewer years of experience needed to sit for the exam, but critically, a CIWI must always work under the direct supervision of a CWI or an SCWI. They can't sign off independently.
And SCWI.
That's the Senior Certified Welding Inspector. This is the top tier. It requires significant experience. We're talking at least 15 years total in the field, and at least 6 of those must have been as a certified CWI.
And another exam.
Oh yeah, a separate, pretty demanding exam. The SCWI is often the person managing inspection departments, overseeing multiple projects, or even developing welding standards for a company.
Okay, so focusing back on the CWI exam itself, what are the prerequisites? The education and experience needed.
Right. This is key information for anyone planning to take it. It depends on your education level. If you have a high school diploma or an equivalent, you need a minimum of 5 years of relevant work experience.
If you don't have a diploma.
If you have at least an 8th grade education, the experience requirement jumps up to a minimum of 9 years.
Wow, quite a jump.
It is. And if you have less than an 8th grade education, you need a minimum of 12 years of documented work experience in a welding inspection, fabrication, or related field.
But there's a way to substitute some experience,
Yeah.
right, with college.
Yes, that's important. The substitution rule. If you have post-high school education, like an associate's degree or higher in engineering, physical science, or engineering technology, that can substitute for up to 2 years of the required work experience.
So formal education counts towards it.
Exactly. It acknowledges that classroom and lab learning provides valuable foundational knowledge, potentially shortening the time needed in the field before you can qualify for the exam.
Okay, let's talk about the CWI test itself. 3 parts, and you have to pass all of them.
That's the rule. You need to score 72% or higher on each of the 3 parts individually to earn the CWI credential.
What if you get close, but not quite 72% on one part?
Well, there's a provision for the CWI. If you score above 60% on all 3 parts, but don't hit the 72% mark on one or more, you can be awarded the CIWI certification instead. So it recognizes competence, but at that supervised level.
All right, let's break down the 3 parts. Part A.
Part A is fundamentals. It's a closed book exam, at least 150 multiple choice questions. And honestly, this is often the toughest part for many people simply because of the sheer breadth of topics.
Like what?
Everything we sort of grouped earlier. Definitions from AWS A3.0, safety practices, destructive testing methods, all the different NDE methods and their principles, basic welding metallurgy, quality concepts, even math conversions between metric and US units.
So rote memorization isn't enough.
Not at all. You have to understand the concepts and how they relate. For instance, not just knowing what carbon content is, but how it affects steel's weldability and potential for cracking. It's about applied understanding.
Okay, Part B.
Part B is the practical exam. This one has at least 40 questions, and it's hands-on. This is where you show you can actually do the job.
How does that work?
You're given a set of realistic weld replicas, plastic models of various weld joints with simulated discontinuities. You have to use standard inspection tools, provided things like fillet weld gauges, groove weld gauges, dial calipers, machinist scales, to accurately measure the features of these replicas.
And then what?
Then you evaluate your measurements against a specific set of acceptance criteria given in a document they provide, usually called the Book of Specifications or something similar. You have to decide if the replica passes or fails based on those criteria and your measurements.
So using the tools correctly is key.
Absolutely critical. This part tests your practical skills under pressure. Can you use the gauges accurately? Can you avoid parallax error when reading a scale? Can you correctly interpret and apply the tolerances from the Book of Specs? If you misread a gauge or misapply a criterion, you fail that replica, just like you'd make a bad call in the field.
Sounds intense. And finally, Part C.
Part C is the code book exam. This one's open book with at least 46 questions, but don't let open book fool you.
Why not?
Because it's based on your ability to quickly and accurately navigate and interpret a specific welding code that you choose beforehand. The most common choice by far is AWS D1.1, the Structural Welding Code for Steel.
What does D1.1 cover?
It covers pretty much everything for general steel structures. Design considerations, pre-qualification of procedures and personnel, fabrication requirements, inspection criteria. It's the backbone for a lot of structural work.
Are there other code options?
Oh, yes. Depending on your industry, you might choose API 1104, which is for pipelines, or AWS D1.5 for bridge welding, or the ASME Boiler and Pressure Vessel Code, Sections 8 and IX, are common for pressure vessels and related qualifications.
So you really need to know your chosen code inside and out.
Inside and out. You won't have time to leisurely read paragraphs during the exam. You need to know the structure, where to find specific tables or clauses quickly, and how to apply them to the questions asked. And again, understanding the terminology is paramount.
Which brings us back to resources like AWS A3.0, the definitions standard.
Invaluable. Seriously, for anyone studying, having A3.0 and knowing those standard terms will help immensely across all three parts of the exam, especially A and C. Using the right language is crucial.
So wrapping this all up, it's clear the inspector's job is incredibly complex and demanding.
Absolutely. It requires that mental sharpness, ethical backbone, physical readiness we talked about, all supported by a really solid working knowledge of everything from, cutting processes and metallurgy to the nitty-gritty of documentation. That first chapter really lays the groundwork for the whole professional mindset.
Definitely. And maybe to leave you, our listener, with a final thought to chew on, we kept mentioning the importance of standardized terminology, like from AWS A3.0.
Yep.
So here's the question. Why is using the precise correct term for, say, a discontinuities location, like correctly calling it a crack in the weld toe versus the weld root? Why is that specific distinction so absolutely critical that the source material hammers at home?
Good question.
Think about the downstream effects. If the documentation, which is a legal record, uses the wrong term, what happens to the repair plan? What happens to the cost? What happens to the structural integrity if the wrong area gets fixed or fixed incorrectly? That small difference in terminology carries enormous weight and potential liability. Something to consider. Before we wrap up, a quick reminder that AMS Level 3 is here to support your non-destructive testing needs, whether it's Level 3 consulting, training and mentorship, or compliance solutions like NADCAP and FAA readiness. To learn more, visit amsl3.com. And don't forget to follow our YouTube channel for more insights and updates on non-destructive testing.